Welcome back. Let's go over some tricks you need to know to work on this semester project. I want to go over some Fusion tricks as well as talk about the workflow, that is, where to put your files and how to share certain things with other students and then how to not share certain things with other students. So we're doing this little gearbox here, and this is the instructions that you need to read and make sure you understand. But there's a bunch of parts in this thing, and everybody's going to be working on different parts. So let me pretend that I'm a student and I've been assigned by the leader or somebody, the instructor or something. Somebody has told me to make this thing right here. Okay, so I'm going to make this Paul shaft. Right, that'll be one part. And then there's this screw. Where is it? Right here. This screw is going to be another thing that we're going to use. All right. So let me get this set up here. I've got the Paul shaft here. I'm going to move this off to my hidden monitor, and we'll get started on that. So right now I'm in my student folder W0002782. That's my student ID, and that's visible only to me, and it's visible to the instructor because I've explicitly invited the instructor to this folder. All right, and let's just back out and look at what's going on here. So we need to make sure that you're in the right team. So I'm in Team Prof. Ross at Bob, and then there's a million or a whole bunch of folders in here, one from every student, and I can't read all of these because as another student I should not be able to get inside any of these things because they have not invited me, and that's the way it should be. But there's also these gearbox group folders that the instructor has created and you've been invited to. So I'm pretending to be a student, and right now the instructor has invited me to this Gearbox Group 0 folder. So I'll get inside of that. And there's nothing in there right now, but what's going to be in here is a bunch of folders or files that other students have created. Okay, so let's back out of that. I'll get into my personal folder that I created a while back for my student stuff. I'll get in there. Okay, so I'm in my student project here, and I can make whatever I want, and it's only visible to me. All right, so let's make this this little Paul shaft thing here. So I want to create a new sketch. I'm going to draw it on this X, or rather the ZY plane, the blue green plane. So click on that. Throw a circle on there. Make sure you're snapping to the origin here, and then I want the diameter to be 0.25, just using the dimensions that are given in the completed drawing. All right. Then another circle right here, and I want this guy to be 0.11 diameter. Once again, using the dimensions in the drawing from the project instructions. Okay, now there's a slot in this thing for a screwdriver, so I want to draw a couple of lines. The first one's going to be a construction line, and initially draw it like this. Draw it about there, so it's approximately horizontal, and you just want to make sure that it's coincident with the circle. So you want to make sure you're getting this X snap that shows that it's coincident with the circle. All right, so that's a construction line. Then draw another line up here, also coincident with the circle. Okay, and escape out of that, and then another line down in here, coincident with the circle, like that. Then set some constraints. So we want this line here to go through the midpoint. We want the midpoint of this line to go through the center of the circle. So we'll use this midpoint constraint. We pick the line, and then pick this dot here, the center point, and it does that. Okay, then pick the horizontal constraint and pick this same line and make it horizontal. Then the parallel constraint, we want this line to be parallel to that line. And then this symmetry constraint. We want this guy to be symmetric to this guy about this guy. Okay? Then add a dimension on there from this point to this point and drop that on there. And I'm going to make it 0.125. And I'm just checking to see that nothing strange happens. I'm checking to make sure that this center line doesn't jump around or anything weird like that. I'm going to update this dimension to 0.0454, which is given on the drawing. And that's the width of the screwdriver. I just measured a screwdriver with a caliper, and that's the dimension I came up with. So that should be wide enough for a screwdriver to fit in there. And there you go. That's that. Now we want these two guys. Hold down Shift and select both of these guys. I want them to be regular lines, so I'll turn off the construction. Okay. So there you go. That's fully constrained, and we can do a little bit of testing. We can change this to 0.3 and see if it does what we expect, and it does. So it looks like it's working okay. Another thing you can do, other different kinds of checks, you can go up here and do inspect and measure and click this line, and then you got to scroll down here and so it's 0.25, which it should be. And you could do other checks on things. Anyway, that looks good. So I'm going to finish the sketch, and I'm going to save this. Look, I'm going to go to home view first, and then I'm going to save this. So I want to save it in my my student folder. That's where I keep private stuff that I don't want other people to copy yet. So I'm going to name this Paul Shaft. All right, and then let's finish it up with a couple of extrusions. So we click extrude. I want this thing, all of this stuff. All of this stuff, I want to extrude the length of this shaft, which is 3.0825. Okay, there's that. There's that. Then it turns the sketch off, so turn the sketch back on. And then we want to make this hole here, so we'll do another extrusion. Pick that and that and that. Oops, not that, but that. Those guys. And I want it to be, the depth of that hole is 0.5. There it is. Then we want this slot on the other side, so we're going to do another extrusion, and we'll pick these pieces of the slot here. Then for the start, you want from object, and then the select comes up, and you click this surface here. Okay, then you want cut, and you want the direction to be, let's see, one side you want the distance to be the depth of that slot, which is 0.125. I think it's it's going to be negative. Yeah, like that. Okay, so from object, and then select the this opposite face over here, and then use a negative distance. Okay, that's that slot. Now you can check it to make sure everything's cool. You could go change the visual style to say like that. And you can turn the sketch off, maybe for clarity. Turn the sketch off, and just kind of check it over, make sure it looks okay, and it does. So I'm gonna put it back on. I'm gonna put it back on shaded with hidden edges. And one more thing I could do, I could kind of look in the hole and make sure that the hole looks like a hole, and it does. Okay, we'll go back to home view and save this. Okay, so that's one part that I'm responsible for doing, say, in my group. Now you're also responsible for doing the drawing, so I'm going to go ahead and make a drawing now. So drawing from design, full assembly is fine, and then click this template that I've created for you. You might have to browse for it if it's the first time you've done it. Anyway, click that, and it does this, and that's too small, so we'll change the scale to 1:1 is probably good. throw that on there and click OK, and then go to this projected view thing, click the parent view, and then we want to see that end of it, and we want to see, say, that end of it, and maybe throw an isometric up here for clarity. Okay, that's that. And then just dimension this thing. So let's see, we'll put some diameters on there. There's that guy, and another diameter, that guy. And let's see, I don't know why it's making a box around that. Okay, got to hit escape a bunch of times. Anyway, then some linear dimensions like this thing, the width of the thing, and the width of the slot, and maybe the depth of the slot, and the depth of this hole in the end. Okay, that's that. That's pretty much, that's it, right? That's fully dimensioned. Yep, good enough. All right, then we'll save this. Now save it in your student folder here, your W folder. And it's Paul Schaft drawing, that's good. Save that. Okay, so that's the first part of this project. Now, I'm gonna go ahead and close these out. And then what I want you to do is take these two things that you've done, the Paul Schaft and the Paul Schaft drawing, and I held down Shift to select both of those, and then click, right click, and then click copy, and then put these in your group. So I'm using Gearbox Group 0, which is just for me to do these silly videos. So okay, so but you put it in your group, whichever group you're in, which I think you should only be able to see the group you're in, I think, if I set up the permissions correctly. Anyway, I'm going to put it in group 0. You'll put it in your group, whatever group that is, 1, 2, or 3. Okay, so we'll copy it in there. Now let's just go in there and see if it's in there. I'm going to go into group 0, and there it is. All right. So the idea is that these two parts could be used by somebody else to make an assembly. All right. And every one of you is going to make the entire gearbox. You're going to assemble the entire gearbox using a bunch of parts that other people have created and dumped into this, they've dumped copies into this gearbox group project. All right. Hope that makes sense. That's the workflow for this thing, essentially. Okay. So this is the, before I go on, this is the first, I think I broke this up into an assignment. I just want you to, where'd those guys go? I just want you to print these two guys out, print out the Paul Schaft or whatever part you're doing, print that out, and the design for that part and the associated drawing for that part. I think that's the first assignment for this project. Now the second assignment is make a little assembly, and I'm going to go ahead and do that right now. Okay, so I'll go back to W, the W folder, because you don't want to share the assembly with everybody, because I want everybody to do their own assembly. Okay, so I've got I'm in my W folder, and I've got a brand new design here. So I'm going to save this design. You have to save it before you can pull anything else in there. So I'm going to save it, and I'm going to call this. I'm going to call this assignment. I don't remember what the assignment. Let's just say assignment 42, whatever it is. Assembly. Okay, then here I don't want you to name it 42. Name it whatever the thing's name is supposed to be. Assignment something assembly, and put it in your W folder. Okay, save that. Then you could go back to group Gearbox 0 or whatever your group is, and you could start pulling in components and assembling them. Right now we just have the two that I made, but this will be filled up with a bunch of components from everybody else. So let's just pull the Paul Schaft in there right now and throw it in there, and you just drag it in there. You click and drag, and there it is. All right. And you can escape out of that. Okay, then you could drag in other parts now and assemble this thing. Let me do the screw. Remember the screw? Let's see. This where is it? Looking for the screw. There it is. That guy. So this drawing here you could actually pull up from McMaster-Carr's website. Just search on this part number and put that in your assembly packet for the project. But we also need the design, right? And that we can pull up. So if you go up here to insert, we can go to insert McMaster-Carr component. It's kind of cool. And it gives you a warning the first time, and so just say okay on that. And then you can type in the part number, which is 9236A148. Type that in there, enter. And this little dude comes up, right, with the pricing and everything. Is pretty awesome. I used to do machine design for factory automation, and we use this stuff a lot. We used to say that if it's not in McMaster-Carr, then it doesn't exist. All right, so click on product detail and then scroll down, and it won't take a SolidWorks. You have to change it to step. Okay, 3D step, and then just click save. And magic, that happens. Okay, it just throws the, well, I picked the wrong screw. That looks too short, doesn't it? You know what? I'm going to keep going on. It's almost the same. I don't want to redo it, but use the right one, right? Anyway, so we're in a move mode here, which we could get into there. We could get into these dialogues and do that. But let's say I had to do it again. So I'd click here, get it selected, and then select move. You could actually just type M. All right, then go to this, go to rotate. Let's see. No, go to free move. Go to free move. Okay, click the little free move thing, and then grab the right button here. Turn it up 90 degrees that away, and then go to point to point, and pick this circle, right? Because we want from really the center of this circle. So pick this circle, and then pick this circle, and it moves it, and then click OK. Okay, so we've assembled that. Now that wasn't a joint, that was just moving things around. All right. Now if you want these things to move relative to each other, like if it was gears or something, then you'd have to assemble that with some joints, right? Like you did in the Towers of Hanoi program or homework. Okay, so what I've done right here is just the simplest kind of assembly that I can do. Now let's make a assembly drawing for that, right? So we'll go. Let me save this, and once again, it's saved in not the group 0 folder, because that's other people could copy your stuff. So I don't want them to. I don't want other students to copy your assemblies. So go back to where this guy's saved, and it's one of these things. It's right up here, assignment XXXXX assembly. Okay, now let's make a assembly drawing from that. So we'll go design, drawing, from design, full assembly, this template, okay. All right, then go to one of these ISOs, like maybe that one. That's pretty good. And bigger, I think, maybe 1:1, maybe even 2:1. Yeah, why not? 2:1, drop that on there, click OK, and then you could double click this and change these things around if you want, but let's see, then go to the table and click table, and then click this endpoint, then click the table again to select it, and then double click it to edit it. Turn off description and material because it's kind of useless for what we're doing, and click close, and that's it. All right, so what I just did here is basically the next assignment for this project, the next, what I'm calling the benchmark assignment. Okay, so I want you to do the simplest kind of assembly that you can, and then make an assembly drawing of just whatever you have available at that point in time. And and then print these out, or capture these and turn in this. It won't be these exact parts, right? It'll be whatever parts that you were assigned by your group leader, or I might end up having to get involved there a little bit, but whatever parts of the total assembly that you're supposed to be doing. So anyway, I was saving this, right? So I'll save it, and I'm saving it in the W folder, right? That way it's only viewable by you and the instructor, or visible by the student and the instructor, okay, which would be you and the instructor. But right now I'm pretending to be a student as well. Okay, so I'll save that. All right, makes sense? So once again, I've got the W folder, and I've got the original parts in there, the Paul shaft, the original, and then the Paul shaft drawing, the original, and then I've got the assembly drawing, and the assembly design, and then the assembly drawing. I've got those, and then what I've copied some of that to the group gearbox folder. I've copied just the parts drawings and the part design and the part drawing, right? So in here, once again, in this group gearbox folder, eventually there's going to be all the parts from everybody, and then everybody's going to do a few parts, and they'll all get collected in here, or at least copies of them will get collected in here. And then I want every individual to make one of these assemblies, right? Every individual will make an assembly, and every individual will make their own assembly drawing as well. But you can use the parts drawings that other people have done. You don't have to duplicate the parts drawings. Those you can use. You can use the parts drawings that other people have posted on here. I just want you to capture those images and put them all into a big document that has the complete gearbox. It has the assembly drawing for the entire gearbox, and then all the parts drawings, basically just the part drawings. Okay, the part drawings, the assembly design, and the assembly drawing. Okay, whatever the instructions say, but I think that's what the instructions say. All right, so that's it. This is enough. I think this video, I'm hoping, is enough for you to do the whole project. I think should be enough. If it isn't, I'll post something else. But all right, I hope that's useful. I'll see you next time. Bye.